So, well, a unified theory of all the forces is what I and many others have been working on for many, many years. And eventually we will find such a theory. It might not be a field theory, probably not, because one of the forces, the force of gravity, is very hard to understand in the framework of quantum field theory, which is the quantum theory we use to explain the nuclear forces and electromagnetism. That's why string theory is so exciting, because that's a framework in which gravity and the atomic and nuclear forces fit together very nicely. Such unified theories have other forces, if you want, or other phenomena that are not just explained by the standard model. And we expect any day to discover extra phenomena that are not explained by the standard model. We haven't directly seen it yet, but we expect it. I expect that at the LHC we will discover many new particles with new forces, if you want, that we haven't yet seen. But so on the one hand, we expect from the hints we have from nature that the forces we know and understand are all unified. But we also expect that unified theory contains a lot of new stuff we haven't yet seen. And if we saw, we would call new particles, new forces. But eventually, it's all just one thing. So both will, I think, we will understand better in the next decade. The new particles, the new forces, and more hints as to how they are all unified. Maybe in the string theory framework.
Ask a question to Professor Cross. It's not about particle physics, it's about global warming. And as I am teaching thermodynamics, and I would imagine that the Earth is not really isolated system, but it's a closed system, and we have this radiation from the sun. And by absorbing radiation from the sun, we emit also some radiation from the Earth, but I do not believe that the rate of radiation in and out are equal. So there will be some trap into the Earth. And I have just my personal hypothesis that all the form of hydrocarbon compounds are actually a picky box for the entropy. And if we have another alternative energy from destroying or cutting down the chemical bonding between H and C, we will just release the debris to the Earth, and the Earth is actually full of to change the potential energy into the form of kinetic energy. And if you just cut down all this bonding, and you create entropy to the Earth, and if you cannot release this entropy out, the avalanche temperature will increase, and this statistically will make more variation into linear molecule where you have new disease. That's just my story, but I don't know what about your opinion.
Well, I think, I'm not sure I understood completely what you said, but we're not, we're a rather small player on the Earth. So the Earth itself is heated. Most of the Earth is this massive core made out of iron and that is totally heated and regulated by radioactivity, by radioactive elements that are decaying. And the sun plays almost no role in the temperature of the Earth. We live on a teeny little infinitesimal layer of soil on the surface, and with a very teeny little atmosphere around us. That is a very precarious element on this massive planet. And that is affected almost entirely, although, eruptions can change, can affect it also on a geological timescale, by the sun. Now, the energy that comes from the sun is so much larger than all biological activity that until this growth of population and energy consumption continues for many, many thousand years, we're not going to drastically affect things the way you said, the way you were contemplating. What we're concerned about on this very delicate atmosphere is very small changes in the temperature, which are caused by basic physics of reflectivity and absorption of sunlight. Very small changes, like carbon dioxide, which is a greenhouse gas, or other greenhouse gases, can have a big effect on the temperature. But big for us is just a few degrees. This is the system of this atmospheric system is very unstable. It's very delicately balanced. We know historically has gone through large changes. What we don't know is what will happen as a consequence of what we, for the first time, are doing over a very short time scale. And the biggest dangers are nonlinear effects. There are others which could drive us into a new region of equilibrium that is unknown. There are other planets nearby, like Venus or Mars, which would not be so pleasant for us to live on. We live in what is a narrow region of stability. And, but we're still far away from the region where the energy that we affect directly through industry or through biological activity competes with the sun, which is a steady source of energy, free energy.
So may I ask another question, if you allow? So it's about consciousness. Do you think that all the human consciousness is made from just chemistry?
Yes.
Okay, thanks.
It's all physics. But, it's consciousness is a very interesting, so this, in neuroscience, this is the big question. What is consciousness? Can we explain consciousness? And it is an interesting, it's interesting to think about the question itself. It is only now beginning to be well-formulated question, where we can imagine how you might go about answering it and what an answer might look like. Until recently, neuroscientists rarely talked about consciousness because it was so impossible to imagine explaining consciousness. Now people are beginning to do that and probing the brain with new imaging techniques, new experimental techniques, new mapping techniques. I just received few hours ago an email from a colleague of mine, a physicist, who has become a neuroscientist, who is one of the pioneers of a new field called the connectome, like the genome, the connectome. This new field of mapping is intending to map the brain completely. It sounds totally crazy to me. They would like to map every connection between every neuron in your brain. There are 10 to 100 billion neurons in your brain, and each of them often has connections with another 1,000 neurons. So there's something like a 10 to the 11, 10 to the 14, which is 10 to the 14 is a million, 100 million connections. And presumably, each connection is complicated because there are different neurotransmitters at each connection. So you may be another factor of 10 to 100. You have 1,000 million code plan that would constitute the map of the human brain, much as the genetic code constitutes the map of the human genome. Now, if you had that, presumably the secret of consciousness would be somewhere there. And I believe that it probably is. And we will eventually make the connection. But we're not yet at the stage where I can even imagine what an explanation would look like.
We would have the metrics, I guess.
Sorry?
We would have the metrics.
So the goal of this project is to map out. Now this has been done with very simple organisms, some worms. Every neuron and every connection is all mapped out. Interestingly enough, even in those cases, the neuroscientists still can't exactly explain how those worms function, or whether they have a consciousness.
Thank you very much.
Actually, two, but I'm afraid that we run out of time. So my question is, I'm not a string theory people, so my question is going to be maybe a possibility. I saw a picture you give on the screen about T quarks that are linked together, and you said it's wrong. And then when they are together, when they're trying to move apart, they create what you call a vacuum. And the vacuum, when you create a vacuum, let's say if the vacuum has a finite size and it turns out to be a classical vacuum, then some force particle will fall in. I suppose if this vacuum has a finite size, then it admits a lower limit of the energy of the force particle to come in. Suppose there is a finite size. Then, if that is a limit, then the renormalization, will not be needed anymore. Do you think it is possible? When you create the vacuum, then instead you got
I think the vacuum is not something you create. The vacuum is as I said, it's like in this room. If you remove everything from the room, all the particles, all the people, all the air,